Hi everyone, this is Chandan and you are watching the learning field. And good morning everyone. So this is the masterclass on wave equation of PDE. In a single lecture, we will cover all the things, all the necessary things for the exam point of view with examples, and we will cover some shortcut tricks also, tricks and tips also for the question solving of the wave equation. I can guarantee that after watching this lecture, okay, no questions of wave equations you should struck. Okay, so just wait 1 or 2 minutes and waiting for joining if anyone. So please comment once that audio and video are okay. I am just waiting 1 or 2 minutes and then we will start. So in this session we are covering the PDE. So how? So what is PDE? Basically this class is exam point of view. You can see this lecture before, just before your exam, for your practice session or for your revise. You can consider this task. Okay. So we will cover the only important things according to the exams of CSRNet, GATE and state exam, any other state exam. And this session is also helpful for West Bengal set, Assam set and all the set exams. Okay, Naina, thank you for commenting. So this is the PDE masterclass of wave equation. I must say that this class is designed from point of view. Radhe Radhe Nana and welcome to the learning field. So this class is based on or according to your exam point of view. So I definitely say that this class will be very helpful, and after watching this lecture, each and every doubt from PDE will be resolved. And the types of questions comes in the paper I am taking here, and if there are any question missed, then you can comment in the live chat. We will try to solve that questions also, or any questions skip. I keep any questions in this video, then we will take a separate class for that after commenting or after the demand. Okay, after demand from you. So let's start. And if anyone have any problem, then you can comment. And those who are new in my channel, don't forget to like, comment, share and subscribe. Our target is to reach 10k family member as soon as possible. So like, share and subscribe. Those who are new, please subscribe. So this is the PDE masterclass. Now we are starting the PDE masterclass. Again, good evening everyone. Those who are watching later for the lecture, you are also welcome, and you can also comment if you have any doubt and if you have any query and if you have any demand or any questions, rather than, or if you want this is something needed in this lecture, then I can separately make a lecture after demand, after from your demand. Okay, so let's start. Fine. So first, what is wave equation actually? So we all know this is a general equation of PDE. R, this is functions of x, y, r del 2x del x2 plus s del 2x del 2 del x del y, and t del 2u del y2, and f of this. There are rather functions of x, y, z, p, q. This is a general partial differential equation, non-linear obviously, on general partial differential equation. And from this equation we can classify the partial differential equation. Fine, we can classify, but this boundary value problem is different from that. There is mainly 3 types of boundary value problem. Fine, 3 types of boundary value problem. The first one is heat equation, second one is wave equation, and third one is Laplace equation, and in this lecture we will cover this portion, wave equation. We will make two separate lecture on heat equation and Laplace equation. One master class for heat equation, one master class for Laplace equation. And from the exam point of view, we have only the one dimensional wave or heat equation. Fine. One dimensional means there are this is space coordinate, this is time coordinate. Fine. And there is only one space coordinate, that is this is called one dimensional. In that case, this is also time coordinate, this is space coordinate, t is time coordinate, and x is space coordinate. If there is the term x and y, suppose if we write the two-dimensional or three-dimensional for an example heat equation, like these are the del t u del t2 equal to c square into del 2u del x2 plus del 2u del y2 plus del 2u del z2. This is the three-dimensional wave equation, and you can also find the heat equation and Laplace equation in that case or in the dimension wise. But for the csir net exam or gate exam or set exam, csir or gate or any state exam or set exam, we are only need to read the one dimensional wave equation. Fine. Or one dimensional boundary value problem in our syllabus. Fine. Next. So these are the boundary value problem wave equation we are read in this class. Now in the exam, the 90% questions or 95% of questions comes from the solution perspective of the wave equation. So we are mainly focusing in this lecture the different types of solution of wave equation. And only 1 to 5% questions which are make something differently, but 95% or 95% to 100% questions in the exam, any exam, is a net or gate or any state exam or any set exam, the all question based on the solution perspective. Fine. So now first we comes to, there are different types of many varieties of solutions of wave equation we can see. We are in this lecture discussing all types or try to discuss all types of solution procedure of the wave equation. Fine. So the solution of the one dimensional wave equation with initial problem or with initial condition. Fine. So this is the most commonly used partial differential or wave equation. So utt minus c square uxx, this is equal to 0 where x belongs to r and t is the positive value, and the initial condition is ux0 equal to fx and utx0 equal to gx. Then the solution is, so this is one types of solution, and we all know that we all commonly know the D'Alembert solution. So what is the D'Alembert solution? uxt equal to half of f of x plus ct plus f of x minus ct plus 1 by 2c. This is the c, this is c square here in the present, then this is 1 by 2c integration x minus ct to x plus ct. G, there is another variable we take because of for integration only, not there is no other purpose to taking the other variable, because of there is only x and we the answer is also comes in the variable x and t, therefore we just consider another variable for integration only. So this is the D'Alembert solution. We all know this thing. This is the D'Alembert solution most commonly used, and I think 80% of the questions which are comes in the exam already are solvable by using the D'Alembert's method. Fine. Any doubt? So okay. Fine. Now if we take the note, which is, see, the note is if utx0 equal to 0, then the solution becomes only this part, f of x plus ct and f of x minus ct. Therefore there are only two functions you must remember. One is x plus ct portion and x minus ct portion. Okay, these are the two functions which comes in the solutions of u. Fine. So you all know that this thing. because of if g is not present in the question, or if g is equal to 0, then only up to this type part comes in the solution. Fine. Next, we take an example here. Now let us take the example. Okay, so consider the boundary value problem. Del 2u del t2, this is equal to del t del x2. These are the x and t. So ux0 equal to this, utx0 equal to this. So if we consider, or if we compare the equation, the general condition utt equal to c square uxx, therefore here c square equal to 1, that is c equal to 1, which is given. Here c is equal to 1. Now fx equal to what? ux0, this is equal to, you all know that, fx, and utx0, the initial condition, this is gx, and here gx is equal to 0 and ux is equal to cos of pi x by 2. Then what is the solution? The solution becomes uxt, this is equal to, there are only fx present, there is no gx, therefore this is equal to half of f of x plus ct plus f of x minus ct. The value of c is equal to 1, that is this is equal to f of x plus t plus f of x minus t. And what is the function fx? Fx is equal to cos pi x, so this is equal to half of cos of pi by 2 into x plus t and plus cos of pi by 2 into x minus t. So this is the solution of this wave equation. This is a very nice and common example of wave equation. And now if instead of 0 there is some function present, suppose x, suppose instead of gx equal to 0 it will be gx equal to x, then we add here 1 by 2 c integration x minus ct to x plus ct, and there is this is the most important thing, is this is the homogeneous wave equation. Okay, homogeneous wave equation. Fine, these are the homogeneous wave equation. This is an example of homogeneous wave equation. I think you all know that because of the presence of 0, this is homogeneous. We also discussed the non-homogeneous portions in this video, so just watch this lecture. I must say that after watching this lecture you don't have any questions regarding the partial differential equation, that is wave equation. Fine, thank you. So Nanaji, please if you watch this lecture and if it is helpful for you, then don't forget to like and share with your friends. Okay, next. Okay, so we already discussed up to this. Now fine, next portion. Now it comes to the non-homogeneous portion. Okay, so up to the previous slide we discussed the homogeneous part or homogeneous wave equation. Now comes to the non-homogeneous wave equation. What is the non-homogeneous wave equation? What is the non-homogeneous wave equation? So consider utt minus c square uxx equal to f of xt. See, this is 0 for homogeneous case. For homogeneous case the right side is 0, but for non-homogeneous case the right side is again a function of both the variable x and t. So ux0 equal to fx and uxt equal to gx. So the solution of the non-homogeneous wave equation is what? Uxt equal to, this is the D'Alembert solution portion for the fx. So see, this portion comes from the present of fx, this portion comes from the present of gx, and this portion comes for the non-homogeneous case, for the non-homogeneous portions. Okay, so these are the divider of the divider in the solution of the wave equation, which which portions comes for what. So for fx this comes in half of f of x plus ct plus f of x minus ct, plus if gx is present then this term comes 1 by 2c integration x minus ct to x plus ct gs ds. And for the non-homogeneous case 1 by 2c integration 0 to t 0 to t x minus c into t minus theta to x plus c into t minus theta. So see, this is there is only changes x minus ct to x plus ct is from t minus theta to t plus theta, and we here for integration we take the another variable s theta, and these are the very standard notations. Fine. So this is the solution of non-homogeneous wave equation in the integration form. There are another form for homogeneous case also and non-homogeneous case also. We also discuss that topic also in the solution. So I that's why I say that this is the one Raman lecture, you can say. Now if we take an example, or if we want to solve these questions by using the, so see, there is xt present, that is, this is a non-homogeneous problem. First you have to notice that this is a non-homogeneous wave equation. Fine. So utt minus uxx equal to xt, and minus infinity less x less infinity t greater than 0. See, ux0 equal to uxt, utx0 equal to 0. Then you have to find the value of u23, and I take the examples from csir and get previous year questions. Okay, so these are the very standard equations or standard examples in the slides. Fine. So how can we solve that? So see, this, if fx is present, then these portions come. If fx present, if gx present, this portion come, and if the non-homogeneous part present, then this portion comes. See, in the example, both the fx and gx are 0. Fine. Both the fx and gx are 0. So the solutions become uxt equal to 0 plus 1 by 2 c integration x minus c into t minus theta to x plus c into t plus theta, only f s theta ds d theta, and f s theta equal to what? F s theta equal to s theta. So here c value is 1. If we consider u t minus c square u xx equal to f of xt, then what? C equal to 1, f xt equal to xt, therefore f of s theta equal to s theta. Fine. So this is equal to 1 by 2 integration x means, so we put the value of u23 here, x equal to 2 and t equal to 3. So this is for the simplification portion. Okay, st, so c equal to 1, so this is x means 2 minus 1 into t minus theta. What? Oh sorry, I think I am 0 to t एक portion होगा integration. I am forget to write that. So here also one integration 0 to t. So is 0 to t means what? This is x and this is t. So this is 0 to t integration. What? The x is 2 minus 1 into, I write here 2 minus 1 into t means 3 minus theta. That is 2 minus 3 minus 1 plus theta. So the lower limit is minus 1 plus theta. Fine. And the upper limit is 2 plus 1 into 3 plus theta. So this is 5 minus t minus theta. This is minus theta. 3 minus theta. So 5 minus theta. S theta means s theta ds d theta. So we just need to do this integration to solve this question. So half into integration 0 to 3 and only integration of s. So s square by 2. So I write here 1 by 2 s square minus 1 plus theta to 5 minus theta and s, sorry, theta d theta. Theta d theta. Fine. So this is equal to 1 by 4 integration 0 to 3. And this is 5 minus theta whole square minus theta minus 1 whole square theta d theta. This is equal to 1 by 4 integration 0 to 3 theta square minus 10 theta plus 25 minus theta square plus 2 theta minus 1. a theta d theta. Theta square goes to cancel out, is equal to 1 by 4 integration 0 to 3 24 minus 8 theta d theta. This is equal to 1 by 4 integration 0 to 3 24 theta. So I just directly doing the integration. 24 theta means 24 theta square by 2, that is 12 theta square, minus 8 theta square means 8 theta cube by 3, 8 by 3 theta cube, and 0 to 3. This is equal to 1 by 4 12 into 3 square minus 8 by 3 into 3 cube. So this is equal to, if we cancel 4 from this, so this gives only 3 into 3 square minus this goes to 2, 3 square, and 4 goes to 2 into 3 square. So this is 27 minus 18. This is 9. So the answer is 9. Fine. So this is a non-homogeneous wave equation, the standard solutions or one types of solutions. This method is not only the unique method to solve the questions. We see also in this lecture what is the another method to solve the question. Fine. Thank you. So please don't forget to like, share and comment in the lecture. If this lecture is helpful, I definitely say this lecture is very beautiful lecture. If you come or if you watch this lecture till the end, I must say, after watching the lecture, please leave a comment in the comment section that how the lecture was. Fine. Next, see, we comes to another portion, which is the series solution of the wave equation. Now, so one types of solutions we already discussed up to the last slide, which are the homogeneous wave equation, non-homogeneous equation, D'Alembert solutions, and so on. Fine. Standard solution. Now, what are the series solutions or infinite series solution? Fine. So it says the homogeneous wave equation for finite string. See, the equation is d2u del 2 del 2 equal to c square del 2x del 2u del x2. This is 0 less equal to x less equal to a and t greater than 0. And see, in this case here the x belongs to infinity, 0 to infinity portion. Fine. X belongs to R, but here for the finite string, that is if we bound x, fine, x the D'Alembert solutions for the x belongs to R, and here we bound x, the infinite solution. This is the boundary value problem. These are another types of problem comes in the exam. Fine. So boundary condition is u0 to equal to u8 equal to 0, and the initial condition is ux0 equal to fx, utx0 equal to gx. So this boundary condition is not present in the problem which we solve using the D'Alembert solution. Fine. But here it is present. It is the homogeneous equation for wave equation for finite string. So when you see the questions of wave equation, first you have to identify which type of problem it was. Otherwise, by watching the options you can also, because if you see the options are based on these types of summation, then you have to go with these types of solution procedure. Fine. Otherwise, if you see you have to find the value something at that point, then you can solve by using the D'Alembert solutions and so the other process. Fine. So this is the homogeneous wave equation for finite string. So here x is bounded to 0 to a. Okay. Now the solution is what? If gx equal to 0, then the solution is, and the summation is from n equal to 1 to infinity dn sin n pi x by a cos n pi ct by a. If fx equal to 0, then the solution is summation n equal to 1 to infinity n sin n pi x by a sin n pi ct by a. Now the general solution, This is the general solution. I write in the case 3. If fx and gx both are present, then the solution is summation n equal to 1 to infinity dn cos n pi. You remember this thing, then I say that what is the procedure to remember these types of solutions for your exam. For dn, you remember this thing, you must remember this thing, this solution, general solution, dn cos n pi ct by a plus n sin n pi ct by a sin n pi x by a. See, this portion stands for the function fx and this portion stands for the function gx. Fine. See, when fx equal to 0, if fx equal to 0, this is not present in the solution. See, or yeah, see this one, sorry, this one. If fx equal to 0, then cos portion is not present. See this solution, this fx equal to 0. And if gx equal to 0, then this portion is not present. This portion is not present in the solution. See, only cos n pi ct and sin to okay. So these are the process to remember these types of solution. Fine. If fx stands for the first portion and gx stands for the second portion. Fine. So if fx equal to 0, then this portion not comes. If gx equal to 0, then this portion not comes in the solutions. But dn and en are the half range Fourier series. So 2 by a integration 0 to fx sin n pi x by a dx and en equal to 2 by a integration 0 to a gx sin n pi x by a. Any doubt? I think you must know that how to remember this solution. dn, I already said that. If you have any doubt, then you can comment. So Nanaji, is there any problem to remember this solution? Please comment. Chalo, next. So this homogeneous wave equation for finite string is important, but as per I see in the questions paper of csir, gate or set, no such questions based on these solutions as I see, or 1 or 2 questions comes in any questions, but you have to read this thing because from this portion the questions may comes in the paper. Next, non-homogeneous wave equation for finite string. Fine. So this is the case of non-homogeneous, only presence of fxt. So this portions same as previous. So up to this portion, the solution portion are same, and these portions comes for the non-homogeneous portion. Non-homogeneous portion. So what is that? Summation n equal to 1 to infinity sin n pi x by a integration 0 to t fn is sin t minus s n pi c by a into ds, where dn and en are the same half range Fourier series, and fn equal to 2 by n pi c integration 0 to a f xt sin n pi x by a. So this is the solution of non-homogeneous wave equation for finite string. I think from this non-homogeneous wave equation for finite string there is no such questions comes in the paper, comes in any csir or gate or set, any other state level set exam. But you just see these things for once to remember the solutions. Fine. Because questions not come still now, that doesn't mean that the question doesn't comes in the future. Fine. So this is the case. That's why you must remember once these solutions, the non-homogeneous wave equation for finite string. So we already covered the homogeneous equation for D'Alembert solution, non-homogeneous for D'Alembert, homogeneous for the finite string, and non-homogeneous for the finite string. So we already discussed 4 different types of solutions of the wave equation: finite, finite or infinite, and homogeneous or non-homogeneous. 4 or 5, 6 types of solutions we already covered. Now, some properties. There are some properties of the wave equation. Basically, these are properties for the homogeneous case, and from these points, recently the questions comes in csir paper, and also so that's why these points are very important for any exams like csir, gate, or set. Fine. So the point 1 says that if f and g are the periodic functions of the same period, then the solutions uxt are also the periodic for the each fixed t. Number 2 says that if f and g are the even function, then the solution uxt are also even functions for each fixed t. If f and g are odd functions, then the solution uxt are also odd function for any fixed t. Number 4, if uxt be the solution of utt minus uxx equal to 0, x belongs to this r cross 0 to infinity, xt belongs to, that is x belongs to r and t greater than 0. Then number A says that for each fixed y belongs to r, ux minus y into t is also a solution. Then any derivative k belongs to n, del ku by del xk is also a solution. Fine. For C, for each a greater than 0, ax uat is also a solution. So these are the most important properties or notes, you can say, from the homogeneous wave equation. These are the most important things. So in the csir paper, I think from this point a questions already comes. Ax at is a solution. I think this is comes for wave or heat. I am just forgetting that, but questions come. Otherwise, for wave, either from wave or from heat equation based on this point. So you must read these 4 points. Okay. If f and g are periodic, then the solution is also periodic. See, the proof is like if uxt equal to, or uxd, if you have given ux0 equal to sine function of sine or cos, then in the answer or in the solution, the sine or cos functions must come. So this is the very nice observation regarding the solution of wave equations for homogeneous case. Fine. Next. Now, I am recalling you the Laplace transform. Why? Because Laplace transformation is also very much or very important for the solutions of wave equations. So I say that there are different types of solutions of wave equation, and we try to cover rather all the types of solutions which are very important from your exam perspective or exam point of view. Fine. So I just remember, but just 5 minutes to take. I'll recalling, otherwise you keep this portion. So L of Laplace of f of t, this is equal to, this is the definition, integration 0 to infinity to the power minus st f of t dt. Now we read here some functions and their Laplace transform. L of 1 equal to 1 by s, t to the power n means gamma n plus 1 by s to the power n plus 1, and t to the power n means n factorial by n s to the power n plus 1 if n belongs to z plus. E to the power at is equal to 1 by s minus a, is greater than a sine function a by s square plus a square. Cos at means s by s square plus a square. Hyperbolic function a by a square minus s square minus a square. Cos hyperbolic at means a s by s square minus a square. And And this is the, I think, shifting property. These two are called shifting property. E to the power at ft is equal to f of s minus a, and e to the power minus at, e to the power minus at ft is equal to f of s plus a. Just a minute. আমি ফোন করছি, আমি একটু পরে ফোন করবো, আমি একটা কাজ করছি এখন। ঠিক আছে। Sorry for disturbing. And f of at equal to 1 by a, f of s by a, and this is, I think, scaling property. So this is the, so these are the Laplace transform. I just recalling for 1 or 2 minutes. And the solutions of PDE in case of Laplace transform, which is L of del t2 equal to s u bar. So the u bar xs is the Laplace transform of uxt, and here the variable in which we use the Laplace transform, which is t, find time coordinate. So s square u bar minus s u x0 minus u t x0, L of del u del t equal to s u bar minus u x0, L of u xt equal to u bar xs, t is changed into s x. So we taking the Laplace transform for the variable t. Then for each L of del t del xt equal to, this is general differentiation, d2 u bar dx x square, L of del u del x equal to d2 u bar dx. Fine. So these are does not changing, just u bar is changing, u is changing to u bar. That is the Laplace transformation of u is u bar. Now we use this. So Laplace transforms we recalling means Laplace is needed for our next class or next solution. Fine. So we also solve this wave equation by using the Laplace transformation. Fine. Any problem, we can apply Laplace if x is 0 to infinity and t is greater than 0. This is not for the finite string. So in the case of D'Alembert solution, instead of D'Alembert solutions, we apply the Laplace transformation. Fine. So let the question says that uxt be the solutions of the IVP utt equal to uxx, 0 less x less infinity, t greater than 0. You remember this thing. In this case, we only apply the Laplace. If x is in R or 0 to infinity or t greater than 0, we doesn't apply the Laplace transformation for finite string. The finite string case is the solutions are only the series solution. Fine. So ux0 equal to cos pi x by 2, 0 less x less infinity, utx0 equal to 0, and these are all are 0. We don't need that. So only here given that utt equal to uxx and ux0, that is fx, this is equal to cos pi x by 5. So taking Laplace transform, L of utt is equal to L of uxx. L of utt means what? S square u bar. The Laplace transformation of u is u bar. U bar is functions of x and s minus s u x0 minus u t x0. This is equal to d2 u bar dx square. And for the PDE, we only find the pi, that is the particular integral. So we now solve this differential equation for x by putting the value, after putting the value. So s square u bar minus s u x0 means s u x0 means cos pi x by 2 minus ut x0 means 0 is equal to d2 u bar dx square. Fine. So d2 u bar dx square minus s square u bar, this is equal to minus s cos pi x by 2. So this is a very standard differential equations. We can solve it. So which is d2y like that, d2y dx2 minus some a square into y, this is equal to some functions p. This is the case. So we only find the particular integral. We don't need to calculate the complementary functions here. Fine. So the complementary functions is, so u bar is the solution x and s, and after solving this we take the inverse Laplace transform. So this is the complete procedure. First we take Laplace, then we solve for the differential equation, and then after solving the differential equation we take the inverse Laplace. Fine. So this is the complete procedure. U bar x is, this is equal to, this is we can write this as d square u bar minus s square u bar, this is equal to the function, and d stands for ddx. Fine. D stands for ddx. So 1 by d square minus s square, and the function is minus s cos pi x by 2. So this stands for d square and this is ddx. So this s is constant, treated as constant here. Fine. So this there is very, you should very careful when you apply the Laplace transform. When you taking the Laplace transform in the variable t, but you solving the differential equation for the variable x. So you should careful. So this is equal to d square means we all know that minus s is constant, and cos pi x by 2 means we just read minus of this square pi square by 4 here minus s square, because we all know that the Laplace of this cos square means we should transform minus of a square. Cos ax means minus of a square, and that. So into cos pi x by 2. So if we take minus commons, and then s by s square plus pi square by 4 cos pi x by 2. So this is the u bar. Now we take the inverse Laplace. Fine. So please comment if you don't understand or if you have any problem. So now taking inverse Laplace. Fine. Now taking the inverse Laplace. So inverse Laplace of u bar means u. So this is uxt. Uxt. This is equal to Laplace inverse of L inverse of s by s square plus pi square by 4 cos pi x by 2. Fine. And cos pi x by 2 is constant, as stated as constant, because x is not the variable in which we, with respect to in which we apply the inverse Laplace. So cos pi x by 2 is outside the Laplace inverse. L inverse of these functions s by s square plus pi square by 4, and this is what, cos pi x by 2. This means again cos pi t by 2. This is the solution. This is our solution. Do you remember? Please comment. Or sorry, do you understand? Please comment. We need to find the value u22 and half. We just put the value u22. This is equal to 2 by 2 means cos pi into cos pi, cos pi, minus 1 into minus 1 means 1, and u half 1 by 2 equal to 1 by 2 means cos pi by 4. So, and this is also cos pi by 4. So cos square pi by 4. Cos pi by 4 means 1 by root 2. Cos square means 1 by 2. So these are the two answers. So u22 equal to 1, to half equal to. These are the answers. These are the questions. You can also apply the D'Alembert solution in this problem. So see, there are different types of solution procedure you can apply to find the solution of an wave equation. So we already discussed 5 or 6 types of solutions of wave equations. So how was the class? Please comment, those who are watching live. The class is interesting or not? Please comment whether the class is interesting or not. So there are various types of solutions I am taking in these slides, so that you can get a whole, in only one class you can get the whole wave equation for your exam. Fine. Next question. So I think you will understand. Next question. Now we going to the another case, which is some shortcut tricks or shortcut tricks. So we already discussed the procedure which are very big and calculative procedure. Now we are going to, or we are entering to, the shortcut. So the class is very interesting. I already said that. Now we can solve the partial differential equations or the wave equations very easily. If you see these types of problems gives in the paper, then we can write directly the solution. So see, consider utt equal to c square uxx. This is from minus infinity to infinity, t greater than 0, ux0 equal to fx and utx0 equal to gx. So remember these two things, very important. Now these are special cases. One, what is that? Fx, if fx equal to sine nx or ax is given and gx equal to 0, then the direct solution you can put it as uxt equal to cos nct plus into sine nx. This is the direct solution. If this is fx equal to the functions of cos, gx equal to 0, then the uxt equal to cos nct into cos nx. So which is given? This is present. This is given. This is present in the solution. Fine. And these are cos if f is given. If f is given, these two functions of cos nct. If g is given, then these two functions of sine is given. And which is given? If this function is cos nx, then this is present in the solution. So you must remember these types in this way, that if sine is given in the initial condition, then sine must be present in the solution. If cos is given to the initial condition, then cos is present. The same function is present in the solution. Now you just observe that the sine or cos is given either fx or gx. If in the fx portion it is given, then in the solution comes in terms of cos. If gx is given, then the solution comes in terms of sine. And if g is given, then here 1 by c, one extra 1 by c comes. Fine. Because what is the reason behind that? We all know that g of x, which is equal to utx0. So there is already one partial derivative. Okay. So for this reason, this 1 by c comes. If we partial derivative xt, then this c and this c goes to cancel out. This is the reason behind this. Fine. Now if f is 0 and g is equal to cos, then again cos comes, which is given, it is comes, and since g is given, then sine comes. G is given, sine comes. F is given, cos comes. Sine is given, f is given, cos comes. If f given, then cos comes. Cos, and if g given, then sine. Remember these types. And which is given, which is also present. Fine, in the solution. And if g is given, then 1 by c extra comes. The reason behind this is the derivative of utx0 rather. I think you will understand. So these are the very important, and these shortcut tricks is most useful for the GATE paper, and also the CSR paper may also comes, and any set paper in these cases are also very important. And now another 4 case. If fx equal to a and gx equal to k, then the directly solution is uxt equal to a plus k into t. If fx equal to ax plus b, that is, this is constant function, this is 1 degree polynomial, this is constant, then the solution is ax plus b plus k into t. See, this k comes to kt. Again, in case if the polynomial is a monic polynomial of degree 2 and gx equal to constant, then the solution, these are the only special case. I am again say that these are not the general case. If this comes, then you can write directly uxt equal to x squared plus c squared t squared plus kt. If fx equal to x cube, then uxt equal to, this was x cube plus 3x c squared t squared plus kt. You must remember these things. Okay. Now comes to some examples, which is this. Fine. Let uxt be the solution of the IPP utt equal to uxx, ux0 equal to sin x, and utx0. This is equal to 1. Then what is this? U pi by 2 pi by 2. See, this is only ux equal to sine function. Therefore, what is the solution? uxt equal to, this is fx. Fx comes means cos is coming, and which is given, it is written. Fine. Now, this utx0 equal to constant only. This if this g equal to constant only, then what comes? This only 1 into t, k into t comes. Now the cos means here nct. What is the value of n? The value of n is n equal to sin ax, means this is the general form sin nx, and n equal to 1. Therefore 1. C equal to here c square means 1. This is 1 and t. So the solution is cos of t sin of x plus t. How was the solution? You don't need to calculate it. Fine. Now simply put u pi by 2. This is equal to xt. This is x. This is t. So cos pi by 2 plus into sin pi plus t means pi by 2. So cos pi by 2 0. Simple pi by 2 is the answer. How was the solution? Please comment. This is the most easy way to solve these types of problems. Fine. Now, next question. So these special cases are also very important, and this is the problem of GATE. This is previous year questions of GATE exam. Fine. Next. Again, another these types of problem. See, if uxt is the solution of the wave equation, utt equal to uxx, x belongs to r, t greater than 0, ux0 equal to 0, utx0 equal to cos x, then what is the value of this? So now we write the solution uxt. Now the which function is given, it is also present in the solution, cos x. Now here fx is equal to 0, gx equal to given, that is sine. The fx0 means f stands for cos and g stands for sine, so यहाँ पर sine आएगा, sine. And the value of n, cos nx is the general form, so n equal to 1 or sin nx, c equal to 1, from here c equal to 1. Here n into c into t, that is 1 into t, and here 1 by c present, so 1 by c means 1, because the general solution is 1 by c sin n ct cos nx. This is the general solution. So this is sin of t cos of x. Now u 0 pi by 4, this is equal to what? 0 means cos 0, x equal to 0, so cos 0 sin pi by 4. Cos 0 means 1, sin pi by 4 means 1 by root 2. The answer is 1 by root 2. How many seconds to take to solve this question? Fine. Any comment? Please do comment. Don't forget to give like, share and subscribe this session. I think this is the most beautiful session from my perspective. So don't forget to comment, or don't forget to leave a comment after watching the lecture. Those who are watching, those who are watched this lecture after the live streaming, so please leave a comment. Please leave a comment. Fine. So if we take another example, and most common example, which is that consider utt equal to 4 uxx, x belongs to 0 to pi, t greater than 0, then u02 equal to u pi t equal to 0. So this is the equation. If you remember that this is the wave equation of finite string, homogeneous wave equation of finite string. Now how can we write the special cases? By using the special cases, we can write using the special cases. Fine. So uxt equal to sin x, given means sin x already present in the solution. ux0 means this is fx, so f given, and g0 means here cos present, cos nct. So c is here, c square is equal to 4, c is equal to 2, n equal to 1 if we consider, because this is ux0 equal to the general form is sin nx or cos nx. Fine. This is also questions of gate. So n means 1, c means 2, t. Fine. This is function of x, therefore 1 by c doesn't come. So just a second. So this is equal to cos of 2t sin of x. So u pi by 2 pi by 2. This is equal to cos t means 2 pi by 2 means simple pi, and sin pi by 2. Cos pi means minus 1, sin pi by 2 means 1, so this is minus 1. The answer is minus 1. Fine. Okay. So this is the total one lecture of wave equation. I think all types of solution procedure, homogeneous, non-homogeneous, D'Alembert, series solution, Laplace solution, and also the special cases are covered in the lecture. So I think you don't have any problem after watching the lecture. I think after watching the lecture, you should concern about the all types of solution of wave equation. Fine. So this completes the lecture. If anything is skipped from my side, then you can definitely comment. I'll try to take if any topics or any important points is skipped from my side. Okay, thank you, and don't forget to leave a comment after watching the lecture, because it takes time. It takes a very long time to make or to design these types of lecture. Okay, थैंक यू, बाय। मिलते हैं अगला वीडियो में। आई थिंक मास्टर क्लास 2 मास्टर क्लास also will comes two master class. One is on heat equation and one is on Laplace equations of partial differential equations. Fine. Thank you. And don't forget to subscribe.